All right, welcome back to Mr. P. Helps with Pre-Cal. This is Unit 4, Topic 1, Lesson number 4, Dot Product. Our fourth and final lesson of this topic that we're going to be doing. So we're given a magnitude and we're given an angle. We're being asked to draw a diagram of the illustration. Okay, I can do that. So it's a 245-degree angle. I know that's more than 180, but it's not quite as much as 270. So I know I'm going to end up in the third quadrant. And I know that its magnitude is 12. All right, so it says now find the component form. Now we talked about in prior videos. Now component form is simply magnitude times cosine of the angle, comma, magnitude times sine of the angle. Okay, so simply crunch that in. Cosine of 245. That gives me negative 5.07, and then 12 times sine of 245 gives me negative 10.87. Okay, now that kind of does make sense. Like we've always talked about, is that negative is going to be in the third quadrant, so that makes sense that that's where that's going to be. All right, so this video is about dot product, but we're also going to be doing some more practice of this is vector addition. So we're adding 3 vectors now. It really doesn't matter where you start. It says I'm going to do P plus J plus 2M. Now, and also remember, vector addition, just like any addition, has commutative property of addition. So it really doesn't matter which one you do in what order. So vector P is going to be 1, 2, 3, 1, 2, 3. So it looks like it's right 3, up 3. So it looks like there's vector P. And then we're going to add J to that result, which would be right 2, down 1, right 2. Down 1, right 2 would be that. And that would be vector J. And then 2 M's. So down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Okay, so we have this. And this is M and another M, okay? So our resulting vector is this. So our resulting vector in this case ends up being right 3, down 1, 2, 3, 4. So it looks like 3, negative 4 is our resulting vector. All right, I'm going to do the same thing over here. So I'm going to do K, which is left 1, 2, 3, 4, 5, up left 5, up 2, so that gets me to here. So that's vector K, and then I'm going to subtract N, and so instead of going down 1, 2, 3, 4, left 1, I'm going to go right 1, up 1, 2, 3, 4. Okay, that's not really going to fit, but I'm doing the exact opposite of N. And I got to do the exact opposite of Q. So instead of going down 1, instead of going left 1, 2, 3, left 3, left 3, down 1. Instead, I'm going to go right 3, up 1. 1, 2, 3, up 1 more. Goes like this. All right, so I know it didn't really fit on the quadrants, but it is going to be a resulting vector of negative 1, 5, 6, 7. All right, next page we have simplify the following vector expressions. Vector V plus 2 times vector U. So I'm just going to write the components. So that happens to be vector V is negative 3, 5. And then I'm going to add that to a scalar of 2 times vector of 7, 2. All right, so now it's just a matter of adding these together. So we have negative 3 plus 5, and then plus 14, comma 4, and then that gives us a resulting vector of 11 and 9. 11, 9. Simplify the following vector expression. So we're trying to find the magnitude in this case. So because of the 2 lines right here, that means that we're trying to find the magnitude of vector P minus V. So first thing we need to do is find what is P minus V. So it's P first, so that's the first point, and V is the second point. So it's very important that we work backwards. So that's going to be negative 3 minus 4, comma, okay, so I'm just going to So it's p minus v. So p is the first one. V is the initial one. 4 comma negative 9, and then subtracting vector v, which is negative 3, 5. Okay, so that's going to give us a result of 7 comma negative 14. All right, and then the next thing I want to do is find that magnitude. So that's going to be square root of 7 squared plus 14 squared, which then gives us 49 plus, let's see, 14 squared is 196, which then adds up to 245. Square root of 245 is going to be your magnitude. Find the direction of the vector of the expression. All right, so find the direction. So the first thing I need to do is I need to add these all up. So vector v is negative 3, 5. Vector u is 7, 2. And add that to vector p, which is 4, negative 9. All right, so negative 3 plus 7 is 4. 4 plus 4 is 8. Comma, 8 plus 2 is 10. 10 plus negative 9 is 1. Okay, so the next thing I'm going to do is inverse tangent of y over x. So inverse tangent of 1 divided by 8, which gives me 7.125 degrees. But keep in mind, yep, this is in the first quadrant because you're going right 8 and only up 1. So it does make sense that this is going to be a pretty small angle. And there you go. Simplify the following vector expression, 2u plus p. All right, so 2 times vector u, which is 7, 2, plus vector p, which is 4, negative 9. All right, so this makes 14, 4. And this is going to add up to 8. Oh, wait, no, I'm sorry. This is 14 plus 4 is 18, comma, 4 plus negative 9 is negative 5. There you go. That is in component form. All right, so we're almost getting to dot product. Dot product is what we're trying to focus on this lesson. It says draw vector 2, 5. How would the perpendicular look? Okay, so 2, 5. This is the other thing that we need to talk about, which is finding perpendicular vectors to this given vector. So you learned, I think, back in like geometry or algebra 1 maybe even, that anything that's perpendicular to this is going to have the exact same slope, only it's going to be the same x and y switch. X and y's are going to switch, and one has to change to the opposite. All right, meaning, so if this is 2, 5, then if I switch that, that's going to be 5, 2. But also, you can change either one to the opposite. So either this 5 becomes opposite or this 2 becomes negative. Now, when I draw those, you're going to see negative 5, 2 is perpendicular, and so is 5, negative 2. Both of these orange are both perpendicular to the purple because that's what happens when you switch the slopes around. Find the possible perpendicular vectors. Well, based upon that, then this could possibly be negative 2, 6, or it could be 2, negative 6. Whereas this could be 4, 7, or it could be negative 4, negative 7. This one here could be 8, negative 5, or it could be negative 8, positive 5. Those are the two that would give you 0. Now, the reason why this is important is because whenever you have a resulting vector that is perpendicular, then you know the dot product is going to be 0. So anytime you get a dot product of 0, then that tells you that those two happen to be perpendicular to each other. So what is dot product? So dot product is this theory that if we have two vectors and we want to find the angle in between those vectors, then that's what we would do, is we would use dot product, which is to multiply them. But anytime those two vectors are perpendicular to each other, then, like I mentioned before, they're going to have a dot product of 0. All right, so this is how you use dot product, and it's fairly simple. So you just multiply the two first terms by each other and then multiply the two second terms by each other, and you're going to get a singular number as your answer. Because like I mentioned before, you're trying to find that angle in between, so you're going to get a singular number that represents that angle in between, in theory. All right. So what can we say about example C? Oh, okay. Before I get to that, so this is going to be 3 times 5 plus 4 times 2. So this is going to be 15 plus 8, which then just adds up to 23. That's the answer. So this one's going to be 1 times -4 plus -2 times 3. That gives me -4 plus -6, which is -10 as our dot product. And then the last one, and I think this is going to have that special case. -4 times 1 plus -1 times -4. This is -4, and if we add that to +4, we get 0. So what can I say about this example? I can tell you that without even drawing these, that I know that these two vectors are going to be perpendicular to each other. Let's see, -4, -1 would be something like that, and then 1, 4 would be something like that. So this and this, I know my drawing is not the best, but they should be perpendicular to each. Oh, I went the wrong way. That's why it doesn't look right. Let me do that again, and it will look right. This one was wrong. And I'm going to fix it to 1, -4. That is a perpendicular vector to this, which is what happens when you get a result of 0. And that becomes the end. And thanks again for watching. Please give it a like to help you learn something about dot product or adding multiple vectors to each other. Have a great day.